So just to review, let's open up a browser and Google PuTTY SSH if you're using the Windows machine. And then we'll download, when you should get to the download page, and what you're looking for is the 64-bit putty.exe. And just save it. And then I'm going to execute it by clicking on the button here. Sure, we want to run it. All right. And then what we want to do is hpc-login.rcc.fsu.edu. hpc-login.rcc.fsu.edu. And then go ahead and hit enter, or sorry, click the run button. It's going to prompt you, do you trust this server? Sure, we trust this server. And then you're going to log in as workshop 00, and you can use 001. And I'll be 003 because there are 3 of us here. Okay. And the password is, I'll get that pulled up here in just a second. Okay, recent. Okay. Okay, and the password is Linux Rocks. Now you're on a Mac. Yes. So the correct thing to do in the terminal will be to type the SSH command, and then space, and then a username. So you'll be workshop -002 at symbol, like email at, and then hpc-login.rcc.fsu.edu. Yep. Hit enter. All right. It's going to ask if you trust the server. Type in YES and hit enter. And now it's going to prompt you for the password, which is Linux Rocks. Don't worry, there's 2 of us, so we got plenty of time here. Let me see what's going on. Yeah. All right. These things could be a little bit more performant. All right. Oops. I'm going to do workshop 001. There you go. Yep. Is it taking it?
No, it's just this keyboard. So.
Okay. Well, like I said, there are 3 of us in the workshop, so we'll wait until everybody's ready to go, since it's not going to take a lot of time. Try it again. Press the up arrow, and then hit enter. All right, it's lowercase Linux, capital R, OCKS, £, exclamation mark. Sorry. All right, everybody's in. Good. All right, so let's review. You guys were both here on Tuesday, I think. So what we have just done is we have connected remotely to the Linux server, right? And we're now going to be running commands on that server as if we were sitting in front of it in the data center. If the machine in front of you was running Linux, then we could just open up the terminal and start running commands. Now, actually, you're using a Mac, which means just about everything we do today can be run on your terminal, on your system. Because when you open up the terminal, your Mac behaves just like a Linux system 90% of the time. So, but we're going to go ahead and use the server just for consistency's sake. Hi, are you here for the workshop? Okay, have a seat on this side of the room. Were you here on Tuesday? Yeah. Okay. All right, so what we're doing right now is we're just getting connected. Are you going to use the workstation? Do you have your own computer? Okay. Go ahead and start getting set up, and I'll come over to you when you're ready. Okay. In the meantime, while he's getting set up, we're going to go ahead and review just what we went over on Tuesday. And I think this is an hour and a half, right, is what we have allotted, Nick? Yeah, we got out after an hour last week, so I realize that now. So we might leave around 4 to 4:15 today, so I don't want to blab at you for too long. Anyhow, here's the concepts we covered. Linux is an operating system, just like Windows and Mac. That's pretty intuitive to everybody. There are two types of interfaces, categories of interfaces that we typically interact with computers on. Graphical user interface, which we are all familiar with because we use them every single day. We use the desktop or laptop computer. And I guess you could even say that the mobile phones are graphical user interfaces as well. And the command line interface, which is what we're going over in this workshop. Okay. We talked about some basic commands. The anatomy of a command, which everything else on this workshop builds on top of, is, of course, we have the prompt, which here I'm showing the pound symbol as a prompt, but you'll often see a $ as a prompt. If you look at your screens there, you're probably seeing a $. We have the executable part of the command. We have options, and we have the arguments. Remember, the options modify the way that the executable works, and the arguments are the things on which the executable is acting on. Some commands don't have either. They just have the executable. No options, no arguments. Sometimes you can run the commands with options. Options modify the way the command works. And then, of course, we learned about some useful commands that are built into the operating system that help you understand what other commands do. We have the what is command and the man command. Man is short for manual, and you can type in man and pass an argument of whatever other command you want to see information about. So we went all over all that. Let me pull up my terminal. Of course, it's not going to work perfectly. Okay, and then I'll make the font size bigger again so we can see what we're doing here. Okay, can everybody see that? Okay, so if we run the date command, for example, we get output, and if we run date with an option, let's just use calendar, for example. If we run cal, we get output, and we run cal with an option, it changes the way that works. If we want to see what options are available, we can always go to man cal, and we can peruse the manual page here, and we can see what all the options are. And if I want to get out of the manual page, I can just hit Q. This is one of those rare moments where Linux actually prints useful information on the screen to understand what you're supposed to do. Usually it just thinks that you know, but down there on the bottom you can see it says press Q to quit. And of course if I can say cal Y for year, we get a year calendar, right? See, another useful tip when running Linux commands is that you can always type in the command name and then -- help. Help is an option, right? It modifies the way the cal command runs. And help almost always, instead of actually running the command, gives you a very brief synopsis of how to use it. This isn't so you can learn how to use the command. This is just meant for a quick reference here. And so we get a much more concise view of all of the options that are available. I can also do the same thing with the df command. This one gets you a lot more verbose help output. But if you look, we scroll up a little bit. Here's where I ran the command, and here's all the help output. And it does give you a nice, concise view of all the options. So rather than opening up the manual page for every single command, sometimes you can just do -- help as well. All right. So after that, where are we over here? We talked about some network stuff. We talked about the fact that Linux is a open source, and therefore you're going to have lots of distributions out there. And then we started talking about the file system. So if you recall, every physical disk that's attached to your computer in Windows gets a drive letter attached to it. So if you plug in a USB stick, you'll know that it'll appear in the My Computer window, and you'll get a drive letter like A, B, C, or J, or F, or something. Very intuitive. And what we said about Linux is it doesn't behave that way, and this is actually similar to the way Mac behaves. Whatever hard drive or disk drive that the Linux operating system is installed on, which is usually the single hard drive inside your computer, is said to be mounted at the root of the file system. So if you change directory, if you go to that folder, you're going to be at the root. And then everything else under that is a hierarchical system. Folders inside of folders inside of folders. And you're going to hear me use the term directory, and that just means folder. Those two things are synonyms in the computer world. So here we have an example where we have maybe a network mount, and it's actually mounted. It's said to be mounted at this directory. So we created a directory called MNT and then put another directory inside of that called my server, and then we ran a command to make this directory actually map to a network drive. If we plug in a USB drive, we actually have to create a directory for it somewhere on your file system and then run a command to mount that USB drive so that that folder or that directory automatically becomes that USB drive. It's called mounting disks, and when you say a disk is mounted, it just means that it's available at some path somewhere in your Linux system. And that can be very arbitrary. You can take a USB disk, plug it in, and assign it any path in your system that's empty and doesn't have anything else in it yet. Okay, so we just started to talk about moving around the file system. And I said when you first log into your computer or your Linux system, you get dumped into your home directory. Everybody has a home directory. Every user has a home directory. It's the directory that you do most of your work in. If you use the HPC or some other system, 99% of the work you're going to do is going to be in your home directory. And I think that's very similar to the way that you use your desktop computers, because inside your home directory on Windows or Mac, you have my documents, my music, my videos, everything's in there. The thing is, on Linux, it's a multi-user operating system, so you can imagine there's multiple home directories, and everybody has their own space. If we type pwd and press enter, it's going to show you which directory you're in. And here you can see that I'm in my home directory. If I do an ls, remember ls, I get the contents of whatever's in there. And you can see there are two things in there, just a Lustre home directory and an rsync transfer log, whatever those files are. Now, recall from our discussion on Tuesday that Linux is giving us some helpful hints here, color coding. We don't get icons in a command line interface like we do on a graphical interface. So you need some other hint to tell files and folders apart besides the icon. And in Linux, it's going to make all the directories blue. And the regular files are not color-coded. Now, let's pass an option in to ls. Do ls-l. Okay? And press enter. And you're going to get output that looks like this. Notice that you get the same information out, only it's way more verbose. And this is what we need to talk about right now. This information is actually very useful to understand a lot of concepts in Linux. So we're going to go over this real briefly. Notice here that when I just did ls, it printed the directory and the file here that's in here in columns. But when I do ls-l, everything gets its own line. Okay, so the command is running the same way, but the -l modifies the way it runs and changes the behavior of the program just a little bit. Okay, let's skip over this section right here at the beginning and just start talking about the other sections here. So we have workshop 010, workshop 010. Okay, this right here is the owner of the file or folder. Okay, who owns it? Which user? This here is the group that is assigned to this file and folder. So in Linux, you have the concept of users and groups. Then we have this number here, 4096. Does anybody want to guess what that is? This is the size of the file in bytes. So this folder here is 4096 bytes. Here is the last modification date in plain English for once, instead of some weird arbitrary format, March 28th, 2018. And finally, you get the name here and the color coding. So we know that the Lustre home directory file here in my example is 4096 bytes. It was modified almost a year ago, and it's owned by the Workshop 10 account, which happens to be the one I'm logged in as. Then we have a regular file here, and you can see that's got the same information here, Workshop 10, except the group is different. The group is called root. Okay, fine, whatever. So the owner of the file is my account, and it's owned by the group root. Now let's go somewhere else on the system and take a look at a different example. If we go to change directory all the way to the top of the hierarchy, so change directory / and hit ls again. Okay, here are the files and folders that are at the very top level of the operating system. Okay, and I said on Tuesday that this is the equivalent of doing this in Windows, of going to the C drive. Here's the C drive, and here's the top level hierarchy of the Windows operating system. Here's what it looks like in Linux. And you see that most of the items in Windows are folders or directories. And you can see that most of the items in Linux are also folders and directories. So it's not that different in that regard. Now let's do an ls-l in here and get the detailed output for each one of these and kind of get a better example. So here's what the top level in Linux looks like here. Same exact output, but a lot more information about each one. First of all, you'll see that everything in here is owned by root, okay? And group root, user root. Who do you think root is? Fine. I'll tell you. I guess that's what you're here for, is for me to tell you, not the other way around. Root is always the administrator on every Linux system ever. There's always a built-in account called root. And if you become root, if you log in as the root user, it's got a password, then you become the super administrator on that system, and you can do everything. Now, on your personal computer, when you first set it up, it might have asked you to put in your name and email and all that, and then it ships all that off to Microsoft or Apple for their mothership to ingest information about you. And you also create a username and password, right? And the username and password that you create on your desktop or laptop computer has administrative privileges by default. You know, you can install programs when you log in. You can modify system settings in the control panel, that kind of stuff. That's administrative tasks. But maybe you have a sibling or a friend that wants to use your computer, and you don't want to give them all that power, right? You don't want them to go into the control panel and change your password, or you know, sign you up for 18,000 apps and download them. In which case you might create another account on your system that's non-administrative, and they can log in as that. Now the server you're logged into right now is one of the HPC login nodes, and it has about 700 users. So imagine 700 siblings or friends that all have accounts on your computer. Obviously, you don't want to give them permission to do everything on that system. So everybody gets a limited user account, and only the root user, only the built-in root user has privileges to go in and change system settings and things like that. In addition to that, the root user owns a lot of the files on the system, most of the files on the system. In fact, I would say almost everything on this computer, on this Linux system, is owned by the root user, except for the stuff in people's home directories. There's some exceptions to that, but it's mostly true. Looking at the output here, then, we see that everything's owned by root. We can see that these are modified along in various dates. And then we see that most everything is a folder because it's highlighted blue. Now, if this system did not have color-coded highlighting on it, how would you know it was a folder and not a regular file, right? You wouldn't. Unless you came all the way back here to the very first, this weird thing of characters here. I want you to pay attention to the very first character in that. And you notice that here we have a D for every one of those blue things. That's short for directory. So in the ls-l output, in the verbose listing output, if the first character on the line is a D, you know that is a folder or directory and not a regular file. And you can see the example more clearly up here in our home directory. You know, the Lustre home directory here is a directory, so it has D. And notice regular files, you know, text documents, spreadsheets, and whatnot, they have just a regular dash here. Okay? It's very important to know because sometimes you'll log in and the color coding won't be working for whatever reason. Anyhow, let's change directory into, say, the etc directory here. Okay? So I'm going to say change directory etc. And hit enter. And then we'll do an ls-l in there. Actually, let's do a regular ls first. And you can see that it tries to fit all the file names as many, in as many columns as you can fit on your screen, so you can browse them more easily. But let's do an ls-l and get them all on their own lines. And you can scroll up and down through this terminal emulator here and kind of see that there's all kinds of different colors and stuff going on. I'm going to pause here on my screen output just to kind of reiterate a couple of points. You can see here there's lots of directories. They're blue, and they have the D as the first character. And then we have some green files here. Does anybody remember from Tuesday what the green means? It's OK. Huh? Go ahead. They are executable, right? The green ones are actually programs that you can run. And I said on Tuesday, everything in Linux is a file. Everything. So all of the commands that we have to run are also files somewhere on the system. That's about it for that. Let's change directory into another one. Let's change directory /dev. /dev. Okay? And then do an ls-l in there. Okay, and look at that. We have a lot of yellow files. Everything on Linux is a file. Everything. What's in the dev folder? The dev folder is short for devices, and every single device that's connected to your computer is represented by a file here. And so they all have weird names. They're not intuitive. Nothing in Linux is intuitive, unfortunately. But the keyboard, mouse, monitor, CD-ROM drive, if you have one, I know it's antiquated, USB drives, the graphics accelerator, all of that stuff is represented by a device in here. Now, as a non-administrative user, you can't go in here and mess with things because that would break the computer. And then 700 other users would be mad at you. But I just wanted to show you this example to drive the point home that everything in Linux is a file, even the devices that are attached to it. All right, now let's take some of this knowledge and take a look at it at a higher level. I told you on Tuesday that we're going to take a really quick short tour of the file system here. And here's what that is. All right. So this varies from distribution to distribution, but 99% of the time, this is pretty consistent. And all of what I'm about to show you exists on Windows and Mac as well. I just have it in a different organizational scheme. Anyhow, the root is obviously where Linux is installed, the drive. All right. And then you're always going to have a folder called bin, or a directory called bin. And that's short for binaries. Binaries means executables, right? So a lot of the programs that we've been looking at over the last 2 days are files in this directory right here. Okay. We have the /boot. Never go in there. Don't touch it because that's the stuff that the operating system uses internally to boot itself up and get going. We have /dev, which we now know is short for devices and represents all the input and output on your computer, including the monitor, the mouse, keyboard, and all of that. etc, I don't know why they named it etc. They did it before any of us were born, but it really just means configuration files, right? And so this is kind of the equivalent here of the control panel, all the stuff in there. But since everything in Linux is a file, all of the configuration for your system is represented in files, text files actually, that you can go in and edit, and we'll see how to do that today before we get out. And so you can think of things like, you know, what's the system date and time, right? Or what time zone have I set the system on, or that kind of stuff is all configured inside files in there. Home, /home, on most systems represents home directories, and underneath home you would have a home directory for each user. So if you had a user named Bob, it would be home/Bob, etc. Core libraries, nothing to say about that. A lot of systems have a directory called media, and when you plug in a USB drive or something like that, you can use that directory to mount it at. Also, they all have a directory called mount, MNT, mount, which is another place to mount media. Why do they have two? Another opt, the opt directory when you first install Linux is usually completely empty and you can use it for whatever you want. If you're a systems administrator and you don't know where to install a package, just put it in opt. Proc, we're not even going to worry about, it's internal stuff. I said every single Linux system has a special super administrative user built in called root, and root actually has its own home directory outside of the home folder. Again, don't ask me why, but on this system, if we try to do ls root, we get permission denied because, well, we're not root, so we can't see what's in that home directory. Okay, and then sbin is just like bin, system binaries. These are executables that really can only be run by administrators. That's what that's for, stuff in there. So administrative tasks. And there's programs to do everything for administrators, like add users, remove users, configure the IP address, change the time zone, all that kind of stuff. Often modifies files in here, but they provided convenient tools that you can run to get that done. So anything that the root user might want to run that's administrative is often here. Okay? And just to show you ls/bin, if we look in the binary folder, notice most of the things in here are green because they're executable. And now if we look in the ls/sbin, also mostly executable, they're all green. But the difference is that anybody can run the stuff in bin generally, and only root user can run the stuff in the sbin folder. Okay. Serve is SRV for services. If your Linux computer happens to be a server and it happens to be serving websites or something like that, you might have software that's running continuously, listening for people to connect and then sending data out. That's usually where you install programs like that. Temp is just for temporary files. You don't usually have to mess with it. That's where programs write their temporary data to, and then it eventually gets deleted automatically. And then user. So again, not intuitively, because Linux was an organically evolved system rather that grew up with millions of contributions. But a long time ago, somebody decided that maybe we should have a special location on the file system for all non-default packages to go. So when you first get Windows or Mac, it only comes with the operating system if you're lucky. And then you go out to the internet and you download programs and you install them. And those programs go different places inside the file system when you install them. On Linux, when you install a package, it sticks stuff all over the place. Like if it has configuration files, it might go in etc. If it has libraries, it might go in lib. And it might put data here and there and everywhere. And so what happens is like every program you install in Linux kind of organically becomes part of the operating system almost. Like it octopuses itself all over the file system. And if you want to remove it, you'd have to go in there and like cherry pick out all of the files that it put in everywhere, which would be a big pain in the butt, right? So somebody said a long time ago, maybe we should set up a special directory that all the non-standard stuff that didn't come with the operating system installs itself into there. And that seemed like a good idea, but unfortunately the world was not on board with it. So some programs install themselves into the USR folder, which I don't even know why they called it that, and other programs just octopus themselves into the base system. And that's where we are today. Interestingly, if you look in USR, oops, you're going to see the same hierarchy, except there's a couple of extra folders in here, as you see in the root file system. A lot of the same folders and directories in there as in the root. And so like let's say you installed a program that needed to put some stuff into etc and lib. Well, then it would put it into user etc and lib in that case. And so sometimes you see stuff in there. And if you notice, if I look in here, if I look in the bin folder underneath the user folder, oh my gosh, a whole bunch more programs that would normally go into the bin folder, but instead they got shoved into user bin for historical reasons. So it's complicated. And then var is just another version of library, and lost and found is what Linux calls the trash. I like that name better. It's more fun. All right, there's your 10-cent tour. There's no way you need to remember all of this, but it's good to have a good context in your head if you ever see this in the future. A couple of things to think about. First of all, if you notice when I've been going through the file system here, when I do ls, if I don't provide any arguments, if I just do ls without any arguments, it's going to give me the ls of whatever my present working directory is. So right now I happen to be in the dev directory, and so when I type ls, I'm going to see what's in there. But if I give it an argument, ls etc, it doesn't matter that I'm in the dev directory. I'm going to get whatever's in here, right? So this is a great example of ls is operating on whatever I tell it to. If I don't tell it what to give me a listing of, it's just going to give me a listing of where I'm at. That's the default behavior. And so I don't even have to move around the file system in order to see what's in other stuff. So I can do ls etc. And even though I'm in dev, I can get that listing. Now, change directory, as you've seen from my examples here, is ways to move around the file system. In a graphical user interface, you usually have forward and back buttons on top of your file navigator, and you can double-click on icons and stuff like that. But in Linux, you have to use the change directory command, cd. And cd has a couple of shortcuts that you need to know. So if I'm in dev, I can go up a level by typing cd space dot dot. Dot dot means the directory above me. And now I'm in root, right? If I'm in root and I want to go down a level, I can just type in the name of the directory, and now I'm in the etc directory. Okay? These are called relative transitions, because relative to where I'm at, if I type dot dot, I'm going up one level. And if I type the name of the directory that's underneath where I'm at, then I'm going down a level. I can also do absolute paths. And I can do absolute paths by starting it with a slash. So I can say, from the root of the file system, put me in etc, I don't know, let's see, crony? Yeah, or whatever. And now I'm in whatever that folder that is. I can change directory to home, gpfs, workshop 10. Okay? And you can see when I'm typing the cd command, I'm passing the argument. If I start with a forward slash, that means from the root of the operating system, put me in home, and then put me in gpfs, and then put me in workshop 10. I typed the name wrong, but you get the idea. And then it'll teleport me to that directory without having to take the intermediary steps. And here's another great shortcut. If you are lost and you want to go home, you can always use the tilde. The tilde is that little character next to the 1 if you hit the shift key. The tilde is shorthand for my home. So hit cd space tilde, and then do a pwd to see where you're at, and you'll notice you're back in your home directory again. Tilde always means home. OK. Now, you've seen me use the clear command a lot, right? So we all know how that works. I want to introduce another command to you now that you're going to keep in your back pocket for just a few minutes. It's the echo command. So everybody type echo and then type a message, like say hi. And what does that do? It's intuitive, actually, right? It echoes it back to you. And this might seem like the most useless command in existence, but just bear with me for a few minutes, because it's actually a very powerful command that you're going to use. OK. A couple of things. Every operating system in existence, including Windows and Mac, do keep track of everything you're doing in the background. And the Linux provides a really easy way to see what it knows about you by running this print env command. So just for kicks, I'm going to say, what is print env? And it says print all or part of the environment. So let's go ahead and just run it. And you're going to get a lot of output, probably. Go ahead and run print env and hit enter. Yeah, OK. This is the environment. And I want to explain a couple things in here, because they're actually quite useful to understand. You notice that there's a uppercase string of characters followed by an equal sign followed by some value. And each one of those uppercase characters is something that the Linux operating system knows about you right now. So some of these things are quite intuitive. Like you can see there's a environment value here called user and then your username. That's how Linux knows who you are. This whole thing right here is called the environment. And the environment is just the working background information that the system is keeping track of in order for you to do your work. And so you're going to see all kinds of stuff in here. Couple of things that I want to point out to you. One is you might see this thing called TTY. That's teletype terminal. And it says it's actually pointed to a device. Here's something in that dev folder we saw earlier. And it's actually pointing to a network interface that you're using. I think that's what it's doing. It's got your username here. And you can see here this giant thing called LS colors. And that's all the color configuration codes for printing directories in blue and links in light blue and devices in yellow. And you could actually go in there and mess around with it if you really wanted to. But here's one of the most relevant things in the environment, the path. Okay? And if you look closely, what's in the path environment variable is a list of directories separated by colons. And when you want to run a command, it's going to look in all of those directories for that command to exist. And the first directory that it finds that file in, that's executable, it's going to run that one. And so you can kind of see it looks in this big MATLAB folder first, and then it looks in another folder first, and then we finally get down to, what is it? User local bin, user local sbin, user sbin, and somewhere in there is actually just the bin folder. But when you type a command, it's actually in the background searching all those directories one at a time to see if the command file exists in there. When it does find it, it runs it. Also, you can say which and then a name of a command here, and you can see which file runs that command. In this case, it's in the user bin folder is where the cal command is located at. That's because that's where Linux installed it. Okay. You can actually print out environment variables, so one at a time. So we do echo path. Notice the $sign in front of it. That's how we tell Linux we want to get an environment variable. Every environment variable in Linux is preceded by a $sign. And it just prints out that one environment variable. We can echo pwd, which is an environment variable, and that's how it knows what directory we're in, et cetera, et cetera. Just keep that in mind. We looked at the ls command already. It's one of the ones that you use most often. There's a couple tricks with it, though. If I wanted to just print out everything in the etc directory that begins with C, I can do C wildcard. And it gives me a list of everything that begins with C, both files and folders. If I wanted to print them all on their own line, I do a -1 argument here. And you can see everything that starts with C here. Another thing I do is /ls/etc, for example, C, and then type the tab key twice. And check what that does. It gives you everything that starts with C. And you could do CR and hit tab again twice. Now you're getting everything that starts with CR. And you can keep doing this until you get down to exactly what you're looking for. So double tab is a great shortcut. It also works if you're just typing commands. So just type a C and then hit 2 tabs. And if there's more than just a handful of possibilities, it's actually going to ask you, do you really want to see all of them? Just type Y, and here's every command on the system that starts with C. I could also do CA, tab, and here's everything that starts with CA. And eventually, I'll get down to the commands that start with just cal. And so I don't have to remember every command name. If I know roughly what it is, I can just start typing it and then hit tab, tab, and the system's going to help me out. And if I see commands here and I don't remember exactly what they do, I can always type the command and put in what is in front of it. And now I have a little memory jog. So given the absolute crazy number of commands there are, there's no way to interact with a Linux system without these kind of little helpful tools. OK. Now let's do something useful. Let's create some files, put some stuff in it, and work on the files. All right, so I want to make sure everybody's in their home directory. So do as td tilde to make sure you're in the home directory. Even if you're already in there, it'll be fine. And we'll do a pwd to show that we are indeed in our home directory. And we're going to start working on some files. So let's look at a couple commands here that are going to allow us to manipulate files. So what we've learned so far is how to move around directories in the file system. And we've learned how to understand what the environment is. And now we're going to work on some files. So do a what is file. There's a command called file. It's not very helpful. And it says determine a file type. All right, so what's in here already? We can do a file rsync. Notice I'm going to hit double tab, or just tab once. If we run the file command and we pass in as the argument a file name, it will tell us that is an ASCII text file. ASCII just means plain text. If you see ASCII text, it's just plain text. If I do a file on the Lester home directory, it says it is a directory. See? So I can run the file command on any single file in the entire system, and it'll give me what type of file that is. If I run file user bin cal, remember this is a command. It says it is an executable, and it gives you a little bit of extra information there. But the keyword you're looking for is executable. Okay. Now let's create a file. All right. So we're going to say touch my file. You can actually name the file whatever you want. I'm just going to call it my file. So I'm going to run the touch command, and I'm going to pass in as an argument a file name, and hit enter. Now we're going to pause here and notice something. There are two types of commands in the CLI. There are commands that print information. You get information from them, like the cal command, or the df command, or the ls command. And then there are commands that do an action. We call it making a state change to the system. Okay? Commands that provide information typically print the information out on the screen. Commands that perform an action, however, you're going to notice that unless they error out, unless there's an error, they will not print anything out. How do you know it worked? Because it doesn't tell you anything. Now, Windows and Mac, they have friendlier commands. If you ask it to do something like create a file, and you hit enter, it's going to say file created. Great job. But Linux is no, it's just going to do it. And silence means it probably worked. You're only going to see output for those kind of things in erroneous circumstances. We can double check that it worked, though, by doing an ls in here. Okay? And notice that my file now exists. I'm going to do an ls-l, and you can kind of see, OK, it's owned by me because I created it. It's in my user group because I created it. And here's when it was edited, 0 February. Oh, no, that's the size of the file. Right. February 28th, that's today. And yeah, there's nothing in there, right? We just created an empty file. So it has 0 bytes in it. Also notice that by default, Linux uses 24-hour time. Just why not? Make things more confusing for us Americans. The rest of the world is fine with it, though. All right. So we have created a file. Now, this might be interesting, but you're probably thinking, OK, how's this going to help me write my English paper on Linux? As if somebody would want to do that, because I've learned how to create empty files. So let's put some data into that file, shall we? And this is where the echo command is going to get useful. So we're going to say echo, and in quotation marks, you know, hello world. I don't know. That's very creative, but we're going to go with hello world. You can write whatever you want. And if I just press enter, we know from a few minutes ago that it's just going to repeat whatever I told it to say back on the screen. But let's use that echo command now to put data into my file. So I'm going to hit the up arrow. Remember, you can go up to review recent commands. And I'm going to modify that command now, and I'm going to put a arrow, just the, what is that, the greater than sign, and then my file. OK, so what's going on here is I'm telling it to run this command with this argument. Right? Run the echo command with this argument. And by default, the echo command with that argument just repeats what I told it to say on the screen. But I'm saying to redirect the output of this command into this file. That's what the greater than symbol says. It's a redirection. Now hit enter. And of course, if it works, I get silence back, the silent treatment. And I can do an ls-l now. But notice that my file now has 12 bytes of data in it, right? OK, so we created the file and we put stuff in it. Swell. And if you have, for your next English paper, you can use this technique to write it. OK, just don't mess up because we're putting stuff in. We can't get it back out. But now how do I read the contents of this file, right? So I can say cat my file. And there's the contents. Now, I know what you're thinking. Man is short for manual, so cat can't possibly mean feline. When they were naming this command, what were they thinking? And I don't know, but maybe we can get a clue about what it was by asking the computer what is cat. And it actually has a very verbose way of saying what it does. It says concatenate files and print the standard output. Concatenate and print files. Both explanations, even though they provided us two, really aren't that descriptive. You can say something over and over again, and if you're still not clear any time, but I'm going to boil it down to plain English for you so you don't have to tear your hair out like I did. And we will say that it prints the contents of files. Okay, so this is the equivalent of opening up a file in Notepad, right? Just running cat on it. We created a file, we put some stuff in it, and we ran the cat command, we passed it in as the argument, now we can see what's in there. All right, now I'm going to go up again, and I'm going to rerun my echo with the redirect, and I'm going to say something else. Goodbye, world. Okay, anything like that. And notice, okay, once again, just to break down the anatomy of this command, we're running the echo command. This is the executable. Goodbye, world is the argument I'm passing in, and then we're redirecting the output into the file. I'm going to hit enter, and I'm going to cat that file again. And notice what happened is that my second command clobbered everything from my first command. So this is no way to edit files in practice, is it? Because every time we echo something into the file, it just overwrites the entire thing. Useful to know. Now, does everybody have a file in there called rsync transfer log in your home directory? Yes or no? Yes? Do you see it? So do an ls in your home directory and see if you have a file in there that's already existing called rc transfer panasys, or whatever you want to call it, whatever it's called. All right, so let's do a cat on that. So cat, okay, and then the argument. I'm going to pass the argument. I'm going to type rs and then just hit tab, and Linux completes it for me because that's the only thing that's in there that starts with rs. All right, so don't stop typing so much. Start tabbing. All right, and here we kind of see, oh, there's only 3 items in there. I thought it was going to be a lot longer. This is just a file that's in everybody's home directory right now. Don't ask me to explain why. OK, so there's not much in there. Let's look at another file that has a lot more stuff in it. So change directory to /etc, because we're teleporting from wherever our home directory is to an absolute path on the system called etc, so root etc. Let's do an ls in there. And let's find a file that has a lot of stuff in it. This one looks quite large, services. Let's see what's in services. So cat services. That's a lot better. OK, here's a file that has a lot of stuff in it. Now, because we are running this in a terminal emulator inside of a graphical user interface, we have this nice pretty scroll bar off to the side that allows us to go up and down. But the scroll bar only keeps so much history in the window, so you might not even get to the beginning of this file before it gives up. Now, I don't know. See, yeah, so even though it has some history in the scroll bar, it only keeps like the last 1,000 lines in there, I think. And this file is clearly more than 1,000 lines. So we cannot see what's on top of this file, what's the first lines look like, by running the cat command. Because what the cat command does is it just dumps the whole thing out to the output, no matter how long it is. And so what you end up seeing on super long files like this is just the end of it. Right? So we need to find a way so that we can scroll through the file similar to what we would in a long text document in a graphical user interface. And of course, as you might imagine, there's a command for that. We have the more command. So instead of running cat on services, let's try running more. OK. Now, what we see on the screen is the top of the file. That's what we're seeing. And on the bottom, you see that we have the word more highlighted, and then we're at 0%. We're 0% of the way through the file. So start typing enter. And you're going to start to see that it scrolls through the file. And if you're noticing, I'm holding down the enter key now, and we're flying through this thing, and we're only at 1%. So this is a pretty darn big file, right? Hit spacebar if you want to page through it. Spacebar will go through an entire page at a time. So we can go through a lot faster if we're paging through it, right? But here's a limitation. Try hitting the up arrow. Doesn't do anything, right? With the more command, you can only go down and not back. Can't ever go back up again. That's not very useful. I mean, it's useful in a sense, right? But sometimes you want to go back up. It's just what you want to do. So hit Q to get out of here, just like on the man page. And you notice that it prints a shell down there on the bottom. Notice, unlike the man page, though, it keeps all your last output on the screen because sometimes you might want to refer to this when you're running commands. Anyhow, we're going to clear it. Hit clear. All right. And so what we need now. OK, so cat is somewhat useful because it prints out the information. More is slightly more useful because it. Did you log out? OK, good. I'll see you later. More is slightly more useful than cat because it lets you page through long information, but we can use an even more useful command called, get ready for it, less. So let's run the less command on that giant text file. All right, and just like the more command, we see the top here, but now notice you can use the arrow keys to go up and down. And we can use the space key, behaves the same way. We can page through it. But now we can scroll through this file at leisure and kind of see what we need to see here. All right, so go ahead and hit Q when you're ready to get out of here. And I will say this too. The less command tends to have a lot of really useful features, including you can search, and you can do all kinds of cool stuff with it. You'll have to read the manual in order to learn more about it because we have a limited amount of time today. But just remember, if you're trying to get the contents of files, cat, more, and less. Now, let's look at more useful ways to put information into a file. We're going to skip all that. OK, and we're going to skip that. So in Linux, there are basically two text editors. One is called Nano and one is called VI. Now there's a lot more programs out there that you can use to edit files, but these are the two most common ones you're going to find pre-installed. And I'm going to walk you through the Nano Editor because it's slightly simpler to use than the VI editor. So let's make sure we're in our home directory. We're not. If I type pwd, you see I'm in etc. So to get back to home, I'm going to change directory tilde. And now if I do pwd, I'm in a home directory, and I can work on stuff in here. So let's go ahead and touch a new file. Let's touch something.txt, OK? And hit enter. Now, you notice I put an extension on the end of this, txt. That is completely unnecessary in Linux. Linux does not care about file extensions at all. It's just, that's really for the human. And now we're going to go type nano and then the file name. Again, I don't have to type the whole file name. I just have to start typing it and hit tab, and then hit enter. Okay, and now we are inside of the text editor. So here, you'll notice this is a lot more familiar environment for people that are used to using like Notepad and Microsoft Word and whatnot. Let's put some content in there. I don't care what you type. Okay. And all of your normal keys work like you normally expect them to do. The arrows work, right? The backspace works, the delete works exactly as it would in the GUI. So this might be a slightly better environment in which to write, say, an English paper, or really anything. Now, also, you'll notice along the bottom of the screen, it gives you some helpful tips for using the editor. In a graphical user interface, you usually have buttons or drop-down menus, and we don't have that kind of luxury here in Linux. So hit Control X, and notice the bottom of the screen changes. Would you like to save it? Hit Y, and then it's going to double check that you actually want to write it to this file, and hit enter, and then it drops you back out, back to the shell. Okay, now let's cat that file, cat something.txt. Notice that everything we put in the text editor is in there, right? And we can run less on it, but in this case, it's not really necessary because it's a short file. So cat works just as well on tiny little files. Okay, and then if we want to go back in and edit it again, we just hit Nano, and we go in there and make some changes. And then we hit Control X. Yes, I want to save it. Yes, that's the file name. OK, good. And now we cat it again. You can see all my changes are in there. OK? With me so far? Now, remember, if I do something like this, OK? And again, I'm running the echo command with some string, and I'm redirecting the output to that file. And if I cat it, all of my prior changes are now gone. Linux didn't ask me, are you sure? Linux didn't ask me, you had stuff in there already, and there's less stuff that you're doing. No, it just said, OK, you want to clobber this with hi there. Fine. That's what we're going to do. OK, so back to Nano. And there's the contents in Nano. Save it, get Control X, enter, enter, and then we're out. And so if you ever want to edit a file in Linux, you can use the Nano Editor. All right, now let's do some useful stuff before we go home today, because I think this might be a way to drive all these points together, is to do a little bit of an exercise here. So we're going to use a very fun program built into Linux called Wget. So let's see what is Wget. What is Wget? Okay, and it says the non-interactive network downloader. What this does is it downloads anything and everything from the internet that you want. So if we go out to this URL on the internet in a web browser, what we're going to see is a text file. Well, that monitors. A text file with the on the decay of the art of lying by Mark Twain. It's quite long text file, right? We're going to download this to our home directory, though, using wget. So what I want you to do is to run the command on the, actually run this command right here. I'm going to leave it on the screen so you can type it exactly verbatim, and run wget and then the URL. And then somebody, one of you guys, tell me what it did. Yeah. Oh, yeah, sorry. Yeah. Moving fast here because we have limited time.
That's OK.
Hit Q.
Q.
Yeah.
Ah, there.
All right. So run wget, and then the URL. And tell me what it does. Or what you think it did. Oh, no. Uh-oh. Huh. Oh, yep. Did you see this on the screen? OK. And if you look at, now do an ls in your home directory. OK. What do you see? OK, it downloaded that file, right? It's in your home directory. All right, now let's do a cat on it. Cat, whatever's in there. So this is a file we grabbed off the internet. And OK, it actually printed out the whole thing to the screen. And again, we know this is a very long file, right? So instead of catting it, we're going to go ahead and less it. So let's run the less command and pass in the file name as an argument. And now you can see, sorry, it's less, and then the name of the file is twain4. All right, and now you're in the less interface, and you can go up and down and browse around that file, right? OK? And of course, it's a very long, well, it's not that long. It's several pages worth. All right, if you're in there, hit Q to get out. And then let's do some tricks with this. All right, we're going to learn about another command called grep. So grep is a way of searching for stuff inside of a file. And so let's just search for the word philosopher inside of the twain4 file. And I got the wrong file name up here in the example, but you should use the actual file name, twain4. So run the grep command, grep, type in a word to look for. In this case, in the example, I use philosopher. And then twain4 is the name of the file. So we are running an executable called grep. And we are passing in two arguments. First is the thing that we are looking for. And then the other argument, the second argument, is the file that we're searching inside of. How do I know that? Well, because I can do man grep, and it's telling me, here we use it by pattern file, right? Here's the first argument is the pattern we're searching for, and the second argument is the file. Or grep -- help. This is a very verbose help output, but you get the idea. Anyhow, let's just run it. Philosopher twain4. And you can see it found one instance of the word philosopher, right? And it even highlighted it red. Let's search for something even more common. Let's just search for the. OK? So we're going to look for the word the in twain4. And notice now we get a lot. It's giving me every single line of this file where the word the occurs. And in fact, Linux is doing exactly what I asked, because you can see it's giving me every result where we have the, even if it's part of another word. I asked it to find the. So if we wanted to search for just the word the, we might do something like this. We might surround this argument with quotes. And it's going to search for any instance now of space, and then the, and then another space. OK? And now you can see we're just getting the results back for the. Interestingly, though, that's a lot of results, right? And the output from that grep command is so big, I can't see all the results. And so here's an interesting trick that you can do with just about any command in Linux. So here's a command that outputs a ton of data, lots of lines. And I want to be able to scroll through that output. Here's what I'm going to do. By default, any command that you runs a query that runs something that gives you information, like the grep command gives you information. It's saying it's going to search for the word the and then show you all the instances where that occurs. It's going to print that out directly out to the terminal. But we can redirect that output. We can redirect that into, say, a file using that same greater than operator. So I'm going to run the same command, and I'm going to redirect it into a new file called search results. Okay? So I'm saying run everything over here and then redirect it into this file. So whatever output you'd normally see on the screen is going to be in that file now. Hit enter, and you'll notice this time you don't get any output. But now when we run a less command on the search results file, which we just created, here's all the output. And it's not highlighted in red, unfortunately, because the system's not that sophisticated. But we get all the lines where that string occurs. Hit Q to get out of that. Okay? You can run any command and redirect the output to a file. Like here's the dfh command we ran the other day, right? All right, stick a caret on the end of that, and just do system info or something. I don't care what you name the file. It's going to go away anyways. And now it's in that file. One more example, just to drive it home. Print the cal command. Let's do cal with a Julian argument. cal-j, output it to calendar.txt, whatever you want to call the file. And now if we cat calendar.txt, it's in there. It's persisted on the disk. That file will be there until either you delete it or one of the systems administrators accidentally deletes it. That just happened. OK, now let's do a listing to see what's in our home directory now, because we have a lot of stuff in there from all the stuff we've been doing. Look at all those files. All right, that's very cluttered. In fact, too much stuff in there. I don't care about half this stuff. So let's delete one. rm, and then the file name you want to delete. So in this case, we're going to remove the search results file. OK, go ahead and type rm, and then any of the files you want to delete, just hit, pass that in as the argument. OK, notice something. Did Linux ask me, are you sure? Did Linux say, uh-oh, you really want to delete this file? No, it just did it. And guess what? Did it put it in a trash can or a recycling bin? No, it did not. It's actually gone forever. That is a very nuclear command. Okay, so be careful with rm. In fact, it's kind of dumb that it's so easy to type. They should have made the command super long and unintuitive, because running that command actually deletes the file for eternity. OK. So I want to show you one other thing here that's going to supercharge your Linux usage if you become a Linux user. Let's run that grep command again. So just hit the up arrow until you see that grep command. And then we're going to take off that caret. And we're just going to run the grep again and output the results directly to the terminal. OK? Now, I showed you what to do if you want to persist whatever the output is on the disk inside a file. But we can actually take the output of this command, and we can send it to the input of another command. And this is called command chaining. So let's say we want to take the output of this command, and we want to page through it so we can see the results. Well, we could put it in a file, persist it on the disk, and then run some command on the file to page through it. Or we know a command that we can use for paging. It's called less. And so what we can do is we can pipe that to less. And the pipe symbol, in case you haven't used it, is right over your enter key. Use the shift to get the pipe, the up and down pipe. And so what we're doing here is we're saying, run whatever this command is. It could be anything. Take whatever output is normally printed to the terminal, but instead pass it to the input of this command. And now hit enter. And now you're inside the less program, and you notice you can go up and down. OK? But you're showing the results of the prior command. Okay? Hit Q to get out of there. Okay? And let's look at some more concrete examples of how you might use this. All right? Let's say we have a question that we want to answer. I'm going to go back to the etc directory. You're welcome to follow along. So now we're in etc, change directory /etc. And I'm going to type in ls-1. OK? ls, gets a listing. The -1 option just tells it to print everything on one line instead of using the columns. Sometimes you might want that. And I'll show you. OK. Let's say we have a question that we want to answer about this. Let's say we want to say how many files and folders are in here. Okay. Well, you could Google how to get the number of directories inside of a folder in Linux. But I'm going to show you how to use piping to get that information. So let's do a what is wc. There's a command called wc. And what is wc, there it is. Print new line word and byte counts for each file. Okay? So basically, in plain English, what this does is give you a count of the number of words in a file. And I'll show you how it works. So wc, notice I'm using the home directory, twain4. OK, it's telling me that there's 601 lines, 5,254 words, and 32,000 characters inside of that text file. OK, so now, that's if we notice we ran the wc command and we passed in an argument here, which was the file. Okay, So by default, WC will read those values for any file that you throw at it, if you pass in the file name as an argument. Another thing to notice here, and I'm sorry I'm moving fast because we're running out of time, is that I use the tilde. Remember what the tilde means? My home directory, and then the file name, because we're actually over here in etc, and I wanted to reference a file in my home directory, but I didn't want to go all the way back to my home directory. So I used the shorthand home directory and then the file inside of it. OK, back to what we're doing. WC twain4 gives me line, word, byte. I'm going to do WC-help now. And it tells me all the options I can pass in to modify the way the program works. Let's say I only want to get the line count. I only want to get the line count. And notice there's an option for that. It's -l is the shorthand. Or -- lines means the same thing. Most options, by the way, have a verbose version and a shorthand version. Sometimes, if they run out of letters because they have so many options, they just have the longhand version. And sometimes when the option is super dangerous, like on the remove command, delete whole file system, they don't have a shorthand option. And notice another thing too, remember, Linux is case sensitive. So in this case, capital L is completely different meaning than lowercase l. Anyhow, let's do that. Let's run the same command again. Pass in the -lowercase l option. Okay, WC-L twain4. And now you can see it only printed the number of lines. It only printed the number of lines. Okay? All right, back to this. Back to the question we're trying to answer. So we did ls-1 to get the files printed one per line in the etc directory. And there's a whole bunch of them. And now we want to know how many. Right, so what we have is a command to print each file and folder on its own line. And what we have is a command that counts the number of lines. So we might mash these together to solve this problem using piping. So I'm going to hit clear again. So I'm going to say ls etc-1. Or actually, I don't need to do that. I'm already in the etc folder, so I can just pass in the option. ls-1. Instead of printing the output of that command to the terminal, I'm going to pipe it to wc-l. OK. So what's happening here is, on the left hand, we're running ls-1. That's going to print out all the files and folders in this directory, one per line. But instead of printing it to the terminal for the human user to see, it's going to redirect that output to the input of the word count command. And in the word count command, we're passing in the L option to get the number of lines instead of the number of words. And so one per line, count the number of lines. And go ahead and run it. 286 files and folders. Okay? That's one way to solve that problem. Does everybody understand kind of how piping works? Okay? All right. Let's look at another example that's more interesting. Let's do a cat on the /etc/password file, PASSWD. So remember, cat just prints out whatever's in the file. And we're using an absolute path here because it starts with a /. So we're saying from the root of the file system, go to the etc folder. And then in there's a file called passwd. That's the file I'm referring to. And you can see that it prints out this. OK? Well, that's a lot shorter than I thought it would be. I thought we had more users on the HPC. I guess since we're using LDAP now, huh? Anyhow, let's pipe it to, let's say we want to get it in alphabetical order. Okay? Well, guess what? There's a command for that, to put something in alphabetical order. So what is sort? Sort lines of a text file. Now, as an initial example, we'll run the sort with the argument of my file name, twain4, my Mark Twain. And look at that. It sorts every single line in alphabetical order. Right? So I completely mangled this story here by sorting it in alphabetical order. This is not useful for a narrative like Mark Twain's works. However, you kind of see how the sort command works, right? And now by cat etc password, okay, I can pipe that concatenation to the sort command. So here, I'm just printing the output of that file. And instead of printing it to the terminal, I'm piping it to sort. And of course, you know what's going to happen next is it's going to print everything out in alphabetical order. Okay? Here's another great thing. Let me show you another example. Instead of cat, we'll do grep. Grep I don't know. Let's see. Oops. Let's say we want to grep for everything that has sbin no login in it. We'll copy that. So grep that string inside of etc password, okay? And remember, in the grep command, here's the executable. The first argument's always what we're searching for, and the second argument is the file that we're searching in. And you can kind of see, okay, here's everything with this no login in it. Now let's say we wanted to sort just those particular lines. So I would pass the output to sort, and now I have the alphabetical order for just those lines. So we can search for something in the text, and then we can pipe the output of that search result to sort. That kind of stuff is great. Let's get another file. So everybody go back to their home directory, change directory space tilde. One of the last things we do today. All right. And then run this command, wget -O, that's an O, not a 0. That capital O, remember, not lowercase. And then we'll call it cr.txt. And then download this file right here. And I'll do it too. wget -O cr.txt. Okay, ctr. And whoops. See, I'm still in etc and it won't let me put a file in there. So change directory home. There it is. And if it worked, you get this nice output. And if you do an ls in your home directory, you'll see this. There's a new file in there called cr.txt. Now let's see what's in that file. Let's see what's in that file. We'll cat it. cr.txt. What do you think it is? It's a list of countries. Okay, in random order. And you can kind of see it's quite a long list. Not too long. We could run a less on it, cr.txt, and then go up and down, right? Hit Q to get out of that. Let's say we want to do some work on this file, though. So the first thing we want to do is we want to get the number of countries that there are. So what I can do is I can say cat cr.txt, pipe it to wc-l. Hit enter. Now we know the number of countries. Let's say we want to see, let's go ahead and sort it. We'll say cat cr.txt to sort. Okay, and notice it puts them all in alphabetical order. And just for kicks, let's say that we wanted to see if Italy is still a country. We could say grep Italy cr.txt. Okay, well, according to this source, Italy is still a country. Right? Let's say we want to sort the file and then save the sorted list to our home directory. So we're going to go ahead and say cat cr.txt, pipe it to sort, and then redirect the output of all of that to sorted countries. All right. Again, so cat cr.txt, pipe it to sort, redirect the output of all of that, not to the terminal, but to that file. And then, of course, it worked, which is why Linux is giving us the silent treatment. And if we look in our directory, now we have a new file called sorted countries or just sorted countries. And now if we look inside the contents of that file, it's this sorted list persisted in our home directory on disk. We could log out, come back tomorrow, log back in. That file's still going to be there. Okay. Interesting thing with piping and redirection is that the Linux philosophy, which is actually the Unix philosophy, Unix you might have heard of, predates Linux. It was the commercial version that was copied by some guy named Linus Torvalds, and subsequently he made it free. Disrupted the entire world. The Unix philosophy, though, is instead of writing big, complicated programs, it's better to write tiny little programs that do one thing well. And then you can chain them together with piping and redirection to solve different problems. Intuitively, for all of your basic tasks, there's almost always a command for that already built into the system because somebody already thought of it. So sorting, finding unique lines, searching, all of these problems have been solved by individual little commands. And what you do to solve problems in Linux is instead of writing a big monolith program, you tend to chain these things together. And sometimes you can have multiple chains. You can chain the output of this to the input of that, and then chain the output of that to the input of another program, et cetera, et cetera. Whenever you see an up and down pipe, that means you're combining two programs together to work as a chain. And you can think of it like a conveyor belt, right? The data goes in initially here, and it keeps going through until it gets to the last command. And unless you redirect the output of a last command to a file, that last command is always going to print out to the screen what it did. OK. I don't think we need to go through all this. This is just showing you different combinations of using piping and grep to solve different problems. And I encourage you to download the slides, which we'll send to you, right, Nick? And play with these commands at your leisure. OK? And as a summary here, you can kind of see, OK, the pipe pipes the output of one command to another command. The redirect symbol clobbers a file if it already exists, or creates the file if it doesn't exist, with the output of whatever that command was, or that chain of commands. The append operator, instead of clobbering the file, you notice we have two here, just adds to the end of the file, right? And so if you wanted to keep, like print a file with the current date over and over again or something like that, you can use the append operator, and it won't clobber what's already in the file, just put it on the end. And then, interestingly, you can go the other way. You can pipe the contents of a file into a command, and I'll show you an example of that just for kicks. So we have a file here with all the countries in it, right? And I can actually come the other direction. I can say sort cr.text is piping in to the sort command. So this is going the other direction. It's taking this as its input. And you can see there it's just working the same way. It's the exact same behavior as sort cr.text. I can send it as the argument. I can say cat cr.text and pipe it to sort, or I can come in and do it this way. All of these three in this example do the exact same behavior, but they're different syntaxes for doing so. And in different contexts, different ones are appropriate. OK. All right. While we still have about 5 minutes, I just want to fly through the rest of these slides so you can look at these at your leisure later. Obviously, every user has a user account on the system. If you are interested in getting an account on the server that you are connected to right now, just go to rcc.fsu.edu and sign up for an account. And you can log in to this Linux system whenever you want. Or you can go download a copy of Linux inside of your Windows system. If you have Windows, Microsoft actually puts a subsystem of Linux that you can install on Windows for free and just play with Linux there. On Mac, just open up the terminal. It's all the same. Anyhow, but if you have a user, you can define groups on your system. That's something the administrator does. And then if a user's in multiple groups, that just defines what files they have access to and what folders they have access to read and write. We're not going to get into all of that today. I'm just going to give you the summary, which is, if you recall, when we did an ls-l, every single file and folder has this big scary string of characters at the beginning. The first character always denotes what kind of file it is. If it's just a regular dash, then it's a regular file. If it's a directory, then it's a D. And there's other kinds of files too. But those are the two main types that you have to worry about. And then the rest of this big, long, scary string of characters is just who has permissions to do what on that file. Remember, it's owned by root, and there's a group name root that it's owned by. And the first three characters in that string read, write, and execute. So here's a file that the owner can read, write, and execute. The group can only read and execute it. And everybody else can only read and execute it on the system. Oops, trying to highlight just those last three characters, but get the idea. And so this string of characters tells you who's allowed to do what on the system. And you can refer into my slide the details about what those mean. Okay? So if you ever try to open a file and it says you're not allowed, or if you ever try to write to a file and it says you're not allowed, you need to go investigate the permissions on it and see exactly who owns it and what you're allowed to do. Okay? And it uses fancy octal math. Nobody cares about that. A couple other things. This is for changing permissions and setting file permissions and doing all that jazz. We don't have time for that. And then finally, we didn't have time to get into this today, but whenever you're running stuff on Linux, if you want to run multiple commands over and over again, and you don't want to type them every time, you can create a bash script. So you can open up the Nano Editor, and you can put in a bunch of commands, and you can save that file, and then you can set it to be executable, and then you can run it. And that's called a bash script. In the 3 or 4 day workshop version of this workshop, we get into compiling software. Again, you can run through these examples if you want. All the commands are there, and you can kind of see what it does. So what this does is it goes out and you download the source code for a C program, C programming language, and then you compile it and run it. In this case, it gives you a bunch of prime numbers. And this tells you how to go out and install software by compiling it on the system. So we have a library out there on the internet called GNU Diction. The thing about Linux is that a lot of times software is distributed not in its compiled form, but actually in its raw source code. And your job is to build it on your system. So think about it, instead of like ordering a spaceship toy, you get a erector set with all the parts in it, and you have to build it, right? That's less and less the case these days. Usually if you want a program, you can find a copy of it that's already compiled. But in the olden days, you had to compile everything. And so you download the source code from someplace on the internet, and then you'd compile it. And you can try that exercise if you're interested. It's actually kind of fun. And then if you are going to get an account on the RCC, you can try the exercises here to actually submit an RCC HPC job. So if anybody's actually taking this workshop with the intention of using the high-performance computing cluster, it's in your best interest to look at these slides and run these examples to give you an idea about how to run jobs on the HPC. It's done with Linux commands. So that's the whole point of this workshop. All right. And I think we're just about out of time. So you can, if you want, you can get these slides at this address here. Here's our website. And does anybody have any questions?